Welcome back to ThinkCosmos, where we ponder the universe's deepest secrets and wonders. The hidden architecture of the universe, cosmic webs and the structure of everything. Today, we're going far beyond stars, galaxies, and even black holes. We're exploring the hidden scaffolding of the universe itself, something called the cosmic web. It's one of the most breathtaking, mind-expanding discoveries in modern cosmology. And yet, most people have never heard of it. So what exactly is the cosmic web? How was it discovered? And what does it reveal about the deeper structure? And perhaps the purpose of the universe? Let's begin. Part 1. The illusion of emptiness. When we look up at the night sky, we see stars. Dots of light scattered across the dark. Through telescopes, we see galaxies, swirling islands of matter, separated by immense distances. But for most of scientific history, we assumed the vast space between these galaxies was empty. Just vacuum, darkness, nothingness. That assumption turned out to be wrong. As astronomers gathered more data from deep space surveys, like the Sloan Digital Sky Survey and later the Dark Energy Survey, something strange began to emerge. Galaxies were not randomly scattered. They were part of a pattern, a structure. A vast three-dimensional web of filaments, clusters, and voids, stretching across the observable universe. This wasn't a coincidence. It was a map of how matter, and space itself, is organized on the largest scales imaginable. Part 2. What is the cosmic web? The cosmic web is a giant lattice of matter, mostly dark matter, with galaxies forming along its strands like dewdrops on a spider's silk. Imagine a sponge or a honeycomb, but on a cosmic scale. Filaments stretch for hundreds of millions of light years, intersecting at dense nodes where massive galaxy clusters reside. In between these filaments are cosmic voids, vast, empty regions where very few galaxies exist. These voids can be hundreds of millions of light years wide. The structure resembles a living network. And it's not static. It evolved from tiny quantum fluctuations in the early universe, ripples in density that gravity amplified over billions of years. This is the real shape of the universe. Not a flat spread of galaxies, but a vast, interconnected cosmic web. Part 3. Dark matter, the skeleton of the cosmos. So what holds this web together? The answer is something we can't see: dark matter. Dark matter makes up about 27% of the universe's total energy content. It doesn't emit light, it doesn't interact with electromagnetic fields, and we still don't know exactly what it is. But we can see its effects. Dark matter is the scaffolding of the cosmic web. It formed the initial structure that normal matter, gas, dust, stars, and galaxies collapsed into. Computer simulations like the Millennium Simulation and Illustris have shown us how dark matter filaments form after the Big Bang, and how baryonic matter follows their lead. Without dark matter, the cosmic web wouldn't exist. Galaxies wouldn't form. The universe would be a thin, evenly distributed soup of hydrogen. Part 4. The Great Cosmic Highways. So why does the cosmic web matter? Because it's more than just structure. It's the supply chain of the universe. Galaxies don't just sit in space. They grow by feeding on streams of cold gas that flow through the cosmic filaments like rivers. These filaments act as highways, funneling material directly into galaxies. Without them, galaxies would run out of fuel. Stars would stop forming. Life as we know it wouldn't exist. Even the Milky Way, our own galaxy, is embedded in a filament of the cosmic web. It's connected to nearby galaxies like Andromeda through visible dark matter strands. And just like cities form along rivers and roads, galaxies form along these cosmic connections. Part 5. Cosmic Web and the Fate of the Universe. The cosmic web also gives us insight into where the universe is heading. As the universe expands, the filaments stretch. But gravity is still at work, drawing matter inward along these filaments, making nodes denser and voids emptier. And eventually, as dark energy continues to accelerate the expansion of the universe, galaxies will drift so far apart that only those in our local group will remain visible, but the shape of the cosmic web will remain. Fossilized. A ghost of its former complexity. A skeleton of structure in a fading cosmos. In a very real sense, the cosmic web is the fingerprint of the universe's past and the roadmap to its future. Part 6. Is it conscious structure? Now, let's step into the truly speculative. Some physicists and philosophers have noticed that the structure of the cosmic web resembles neural networks, like the human brain. This isn't just poetic metaphor. Studies have found mathematical similarities between the distribution of galaxies in the cosmic web and the connections between neurons in a brain. Could this be coincidence? Or are we glimpsing a deeper truth? That structure, pattern, and self-organization are universal principles. That the universe itself is like a mind, a vast, self-evolving information network. We don't know. But as we map the cosmic web in more detail, through radio telescopes, gravitational lensing, and dark matter simulations, we may begin to answer one of the biggest questions of all. Not just what the universe is made of, but why it is structured the way it is. Conclusion. The cosmic web is not just a map of galaxies. It's a story of how the universe organizes itself, from quantum noise to intergalactic order. A structure written in gravity, dark matter, and time itself. It is the hidden architecture of everything. And it's still growing. Thank you for joining us on this long-form deep dive here at ThinkCosmos. If this journey stretched your imagination or changed the way you see the universe, subscribe and share it with a fellow cosmic thinker. Until next time, stay curious and keep looking up.